We are still looking at Energy Test B, and now we're on page 2. So here is page 2. First, we wanted to draw an example energy. So I needed to see in your example kinetic energy, gravitational potential energy, or elastic potential energy, one of those things. So in this example, this was good because we see if the object is moving, that's going to be kinetic energy. You can also see the potential energy here. I would have liked to see that this was specifically gravitational potential energy in this example. Here's another one. This is gravitational potential energy because the vase is off the ground. Excellent. Really specific. Really good example here. Then in this one, the car is moving forward, and the problem that I had here was the engine is making the car move forward, therefore it's mechanical energy. No, it's the fact that the object is in motion, and that's kinetic energy. That's what makes it mechanical. I saw quite a few people who had written for their example of mechanical energy that it had to be something that was energy from a machine. And that's not what mechanical energy means. I know the word mechanical kind of makes you think machine, and the word machine does come from the same root word as mechanical. It's that idea of things moving. But anything that's kinetic energy or gravitational potential or elastic potential energy, all of those things are mechanical energy, and it doesn't have to be something that's from a machine. That's not the source of it. The next one was an example of non-mechanical energy. So anything that was solar. Another one was thermal energy. Had another thermal energy example. So electrical energy, nuclear energy, chemical energy, all of those would be examples of non-mechanical energy. Anything that is an example of one of those things. Okay, then we have, as the work decreases, what happens to power? The power increases. So as you're trying to do work over a certain amount of time, the faster that you're trying to do that, the more power you need. And the faster you go, that means time is decreasing, but that means the power to get it done, you've got a smaller amount of time that you got to fit it all into. So the power has to increase to be able to get it done really fast as opposed to slowly. Okay. And then we have an example of Newton's first law. So what I'm really looking down here is that I want to see. You don't necessarily have to have the definition of Newton's first law. A lot of people wrote it. And so if you gave me that definition, I at least gave you 2 points, but I really was looking for an example of Newton's first law. So here's a good one. We have an object rolling and gradually slows down due to the outside force of friction. So identifying an actual outside force in this one. So that was an example. And then let's see. Hockey puck hit across frictionless ice. The puck will keep moving until something stops it. So demonstrating inertia, and really this is the law of inertia. That's what Newton's first law is describing. That objects keep doing whatever they're doing unless there's an outside force that acts on it. Yeah, and so then I had a person forget to actually provide an example, but they did get 2 out of the 3 points just for giving the definition of Newton's first law. Then we had the SI unit for mass, that is kilograms. I did see a lot of people write down just a letter M, and I think what these students were thinking of was in our formulas, we know that M stands for mass in the formulas, but the unit is what we actually measure it in. So you wouldn't say that the mass of is 5 mass. You would say it's 5 kilograms. Actually, that's really heavy. It's probably like half of a kilogram. I'm not sure how heavy a soccer ball is. Or a person, I am not 75 mass, I am 75 kilograms. So that's the unit is different from the symbol that we're using. So kilograms is what we measure mass in, and that's what I mean when I say unit. Then we have how are work and energy related. So this person put down that they are both measured in joules, and work is equivalent to the change in energy. So really what I was looking for here was that relationship that work is the change in energy. The fact that they're measured in joules, that was just cherry on top there. That was also a really good point. So work is, the amount of energy that is used or transferred. I'm really just mainly going for work is my change in energy. I did like this response. To do work, there must be energy involved. When you have energy, some kind of work could be done. So energy is the ability to do work. So I felt that that was also meeting the answer that I was looking for here. So that was good. All right, that's the end of page 2.